Hello, everyone.
Good evening.
Now, I was thinking about giving you some time to read the title, but I think it's better if I explain. So, we are from the Civil Sphere Project, and our goal is to protect people at risk. And we do that by analyzing their traffic. And one of the ways to help increase the efficiency of the whole process is machine learning. And so that's what we're going to explain today.
I'm Frantisek Strasak. I'm a student of artificial intelligence in Czech Technical University in Prague, in the Czech Republic. I focus on machine learning in cybersecurity. And for the last 5 weeks, I started to exercise yoga, so I like yoga. And here is Jan Fajfer. He's also a researcher and student in the same university. And he also focuses on machine learning in cybersecurity and traffic analysis. And he loves drinking in shower. And both of us actually love the beers. And for the last 2 days, we like also the Budapest. It's very nice.
Yeah. So the goal of this whole project, of our research, is for stuff like that to happen less. So when I said we help people at risk, I meant journalists, lawyers, human rights defenders, basically anyone who's not from the corporate world and doesn't have a lot of money to get a good security team and take care of all the ways and of their security. But we also care about other threats, more common, which are headlines like these. So attacks that are not targeting the specific person, but are generally attacking everyone. So what can you do when you get infected? You might panic. That's one thing you could do. There are other ways that a person can do. So imagine a journalist that has their phone, and the journalist might suspect that the phone is infected. So the first thing you could do is get rid of the phone. Throw it in the trash. That might solve the problem, but also the person loses all the data and the device. Another option is to factory reset the device, wipe the disk, which also loses the data, and it's not a good solution anytime a person becomes suspicious that something might be happening, right? Antivirus is another option, which might help in some cases, but usually with sophisticated and targeted attacks, it doesn't really help. Now, a good way to figure out if your device is infected is to perform a forensic analysis. Actually look at the disk, but that also means that you have to give your device to someone. Go somewhere and physically give the device to someone, which is not always convenient. A good way might be to analyze the traffic of the device. And one thing there is that how to give your traffic or show your traffic to the correct person who can analyze it. And that's when our project comes in. It's called the Emergency VPN Project. The goal is to find any vulnerabilities and anything, basically, that we can see that could harm the person that is happening on their device, usually a mobile phone, a cell phone. Now, why network traffic? Well, network traffic is a good indicator of what is happening in the phone. There's a lot of data, a lot of information. So for a network analyst, it is easy to guess a lot of the things that are happening there. Also, with a lot of infections and malware, there is malicious communication, malicious traffic that is happening, so that would also be in that network traffic, right? It's not just a good indicator for an analyst. It's also a way for attackers to get the information from the traffic or use the traffic as a way to infect the device. As you could see, for example, a person, a lawyer, connecting to a Wi-Fi, public Wi-Fi at a cafe, there are a lot of people that can actually look at his traffic and possibly modify it. There is, and usually anyone connecting to the Wi-Fi, and then anyone with the access to the internet service providers, routers, that also depends on the country. But the general idea is that network traffic tells a lot, and it's important to have an idea of what's happening in the phone. So, Emergency VPN is a free service for people at risk. The goal is always to find anything that could harm the person. That means ongoing infections, malware that is already installed and is generating some traffic or sending information to the attacker, or any vulnerabilities that are in the system. We do that by manually analyzing the traffic, and then we craft a report that we share with the person and give them the details of how to proceed. We usually take 3 days to capture the traffic, 3 days of traffic to basically get an idea of what is happening in that device. So the usual process would be a person contacts us, tells us they want an assessment of what is happening in their phone. So they get we send them a OpenVPN profile, which enables them to connect to our OpenVPN server, to our VPN server at our university in Czech Republic. And then the person uses the phone, depending on their suspicions, but all the traffic is first sent to our university, as in a normal VPN. The twist is that we capture all the traffic, we copy all the traffic, but the functionality of the VPN stays. And when we usually take 3 days, we capture the traffic, and that's when the core part starts, the traffic analysis. We have the data, and we try to find anything suspicious and malicious. Usually, at the start, we get an overview of what is happening, right? We can see the device, that we can usually guess the device of the user. We can get information about what application the person is using, and we look at all the protocols the device is using, and we try to separate the traffic. So, for example, if we know that the device is an Android, we know of the background processes, we know the IPs that the operating system usually connects to, and we can take that traffic out of the analysis. Similar with some known applications that we know that the person is using and are not malicious. And then we do a detailed look at the rest of the stuff. Sometimes we go packet by packet, analyzing what is happening. We use several tools to help us speed this process up and make it faster. You probably know some of these, for example, Zeek or Suricata, to help us get an idea of some events or unusual events in the traffic. We use the Stratosphere Linux IPS, and of course, Wireshark when it comes to the detailed stuff. Now, with this analysis, there are several positives and negatives. So the positive side, the upsides, the analysis is pretty detailed. We get a good idea of what is happening. We know what each connection does and why is it happening. And we can confidently say if in the traffic that we saw, if there's anything malicious or suspicious. However, there are a lot of issues. The first issue is that it takes a lot of time. For 3 days of traffic, it usually takes at least 8 hours to go through everything and craft a report for that person. And the main time consumer is HTTPS traffic, because obviously we cannot see the content, so we cannot see if it's malicious or not. We know that it's not a vulnerable connection because it's hard to modify it, but it's generally harder to assess. And a thing connected to this is patterns in traffic, which means that, for example, APT, when a person has an infected device and the attacker periodically gets the location of the person, or there are some patterns in the traffic that might be observable but are difficult to by a human. So how do we make this process more effective so that we can actually help a significant number of people and take the day for one analysis down? So the idea that we came up with was using machine learning.
Yes, we tried to deploy machine learning techniques and detection systems to speed up the analysis of the internet traffic, and also try to learn machine learning system what is the HTTPS malicious connections, because it's pretty hard to say if it's malicious or not. So on the beginning, we were see this picture of the normal scenario of the machine learning process. So in the beginning, we needed data, enough data and reliable data. Then we extract the features from that. So it means that we have to understand the problem and make some research. What is actually malicious behavior? And then train model. It means choose the right high-level features for your algorithm, and also choose the right machine learning algorithm, and then evaluate it. If you are not happy with the results, you can start from the beginning. So it means put more data there, or choose another interpretation of your samples, or choose another hyperparameters for a machine learning algorithm. The most important stuff is dataset. For each machine learning task, if we start from the image classification or to language processing, and if we end here in the cybersecurity, the dataset is core of the research. So it sometimes can be very tough, and you can die during the labeling. Hopefully, unfortunately, we have dataset. It's available, and it's also free, so you can use for your research if you need. And we have enough samples for that. So we have a C214 dataset, an MCFP dataset, which was generated in our university in Prague. So you can use it if you want. But in that moment, we had enough malware captures and enough samples for training, but we didn't have enough normal samples. So it means that we spent some days of clicking on the normal websites, which we know they are safe. And we generate new accounts on fake accounts on Facebook, Twitter, and so on. And then we also ask our department if we can capture the data from the employees there. So we went door by door and asked people, yes, are you human? Because in our department there's a lot of printers and robots, so first we had to ask. And if the person agree, so then we could use his or her IP for our dataset and gather it from that. So after this capturing and analyzing data, we had enough data to train, so we could start with the extracting features and training. On the beginning, each capture has pickup file with the packets, and we use Zeek or Bro program to generate flows from that packets. So we had the flows, how we can see, and for all flows with the same source IP, destination IP, destination port, and protocol, we group it to one object, which we say to it SSL aggregation. So SSL aggregation is only object having all same flows. And from that flows, for each SSL aggregation, also for each group of flows with the same source IP, destination port, and protocol, we compute the features. Actually, we had 40 features, and it was mainly about TLS certificate because we want to detect and classify if the connection is malicious or not, because it's the core of the problem of the analysis. And yeah, and we put some machine learning algorithms. We had random forest, XGBoost, SVM, the basic ones, and we got 95% of accuracy. We got also quite high false positive rate and negative rate, but it's not for real scenario that you put this detector to your router and say, okay, I'm safe. However, it's still very good speed up of the analysis. If 90% of the traffic is filtered and you just can focus for the 10% of the traffic and say, okay, I just want to focus on that. However, there is this year we realized the big problem, and it is TLS 1.3. TLS 1.3 is not a problem. It's a very good protocol from our point of view, and it's a very good thing for users of internet because TLS 1.3 is faster. During the handshake, there is only, if you compare it with TLS 1.2 and previous version, there is only one key exchange algorithm, Diffie-Hellman group, to ask server if what's supported. And so there is less negotiating with the parameters between client and server. So if we can see this picture, the difference is 100 milliseconds for each handshake if we compare the TLS 1.2 with TLS 1.3. So it's a big advantage. And also, TLS 1.3 is safer because no dangerous ciphers are used there. There is only that which we know and suppose that they are safe. So from user point of view, TLS 1.3 is super good. However, from us and from our point of view and as security organization and security companies, I suppose, that it can be very bad side because TLS 1.3 also encrypt the certificate. So we lost most of the features which we use in the research. How I showed, there was 40 features which we used, and most of them was from TLS certificate. And in this moment, with the TLS 1.3, most of them are encrypted, actually hidden due to encryption. So we lost, for example, valid length of the certificate. It means when the certificate starts and expires. So it was one of the interesting, I don't want to say most powerful, but it was very good feature for the detection. For example, then also the SAN domain. So this is the example of Avast certificate from the Avast antivirus company. So this is list of the host names. So we lost this feature as well, and we also lost the certificate chains. So these features and much more. This is just example. We lost them. So we were sad. We cry. My boss cry. I was cry. Honza cry. It was bad. So we didn't know what to do, how to continue to improve the speed of the analysis of people in risk. So we had to create new hypothesis. And the new hypothesis was, okay, let's try to detect or classify all SSL connections only or by only from TCP layer. So no certificate. Let's try to focus only on bytes, packets, periodicity, and so on, and try to detect SSL connections, SSL malicious detections. And also it means that if we have only these features, which are quite raw, because if you have number of bytes and number of packets, it's more raw data than state of the connections, for example. Let's try the deep learning. So, and finish the game with the image classification and language processing. So let's try the deep learning on real traffic, which we use, and real problem. The technique of the creating the samples is same, and also dataset is same. Only thing which we have to realize that this dataset is generated from Windows computers. So we still have to in mind that we try to detect in EVPN the mobile traffic. So we don't know if it will work, but let's try it. So we have a pika file, the Zeek program, which creates the flows. And again, we create the SSL aggregation. And now there is a point for features. The features in this for deep learning has to be different. And as I said, it should be more raw data, no standard deviation or means and so on. So we defined these 6 features. And for each flow in this SSL aggregation, we extracted for them. So this is the example of SSL aggregation. It's from IP 10.0.0.5 to Google for port 443 on TCP. And we have the first flow, and the flow are sorted by timestamp, so it's by time. And we take this all information from the flow. Then we take the second flow by the time, and we took the information from the flow, and we did it so we continue and until we put all information from the SSL aggregation. We are in the convolutional neural network, so we need to have the size, so this input size has to be same. So we have to pad it with 0, and we define it that the input size to our neural network will be 250. So at the end, each sample has 6 sequences of numbers. And these sequences, as the input, we put inside the neural network. So the idea at the beginning was take the structure from ResNet neural network, which is architecture for image classification. So it's not exactly same, but the idea on the beginning was from this architecture. As you can see on the beginning, we have these 6 sequences of the numbers. And at the end, we classify each sample. It means the one SSL aggregation. It's one sample for us as a normal or malware connection. There's one links there that in image classification, you have RGB images mostly. And it's a 3 channels. This is very, very similar because we have 6 channels. It means that we have six sequences of numbers. So there is some similarity. It's not different so much. From our data set, we have 80,000 samples for each class. So we have 80,000 for malware and 80,000 for normal. And we split it to normal machine learning way. So in the training part is for train the parameter inside the neural network. The validation part is only for checking if your model is not, if your model doesn't overfit. So it's trained only on your training data, but on the testing and validation doesn't work. And finally, when our model was trained, we check it on the testing data, which we didn't yet. So we got accuracy 94%, false positive rate 7%, and false negative rate 3%. In our terminology, false positive rate means that we say, OK, this connection is malicious, but it's not true. So we say this in the 7%. And false negative rate is, again, we say it's normal, but it's not true. So the question is it good enough for real usage? The question is, for me is very interesting because if you realize that we took only features from TCP layer and we were able to classify TLS connections in accuracy 94%, it's interesting. At least it's interesting, but it's not able to use in the real scenario, like in the real life, because there's so many false positive samples and false negative false samples.
So let's take a look at how we use this with our emergency VPN. Now, we have a little demo prepared, but we cannot really show you the traffic of the people that we work with. So we did a simulation. Basically, we took a phone and we installed basic applications, used it as a normal user would. We connected it to our emergency VPN, where we started to capture the traffic. And then we took a malware sample and we executed it. So we infected the phone and we were able to capture the malicious traffic. Now with this sample, let's see how the trained model that we have, how it's going to perform. So the script is in Python. It takes the PCAP file, uses the Zeek to extract the features, and then flags connections as malicious. So these are the 13 connections from several hours of the traffic that were captured. And as you can see, there are a lot of false positives. That means the model flagged connections such as inbox.google as malicious, which, when we take a look at it, it's obviously normal, benign traffic. But what's interesting is that the malicious connection that was generated by the malware is also there. It's a connection to the command and control server, which is giving orders to the malware. This is an IP from China, which the malware was using. And so from all the traffic that we see from the PCAP file, with this tool, in a small amount of time, we can get several connections that are flagged as malicious. Now, when with a couple other tools, we can separate the traffic that we already know. And if we would do that, from all the traffic, all that would be left would be probably 3 connections flagged as malicious. Now, from the analysis point of view, this is a real help. From the whole traffic, there are several connections flagged, and basically the model telling me this is a suspicious behavior. Take a look at that. So we took 40 captures that we had to see how this model is going to perform on our traffic, on the traffic that was analyzed. And we found out that the model was able to filter out almost 91% of the traffic as benign. With the combination of filtering out all the background traffic of the operating system, the number of 91% would increase a lot. So, to conclude, what can we take away from this? We can definitely use machine learning to make this whole process of evaluating and analyzing network traffic much more effective and faster. However, it is in no way prepared to serve as a standalone detection program, because it would, from days of traffic, it would still flag a lot of connections as malicious that are not. But it is a good way to combine with the manual analysis. Moreover, there are several exciting ways that we can go forward to move the numbers and the accuracy even higher. Because right now, realize that all the traffic that we had in the data set, the data that we used to train the model, was used when executing malware on desktops, on Windows machines. Yeah. So, and we used it to like detect the behavior in a mobile phone. So there are things that are going to vary. So the next thing that is going to drive this research forward and make the analysis even more effective is using the same model, but training it with different data. That means creating several models for for different models of the phone, operating systems, and protocols. So that is what helps us analyze traffic a little faster and make this world a better place, at least a little bit. So thank you, and
Thank you for attention, and if you have a question, we will be glad to answer if you know.
yeah, feel free to ask.